Okay, let's begin. Today's class is about angle properties and circle angle properties in circles. Okay, what I'm going to do is I'm going to start solving questions and I'm going to tell you the formulas as they come up. Let's first do this question. It says calculate the interior angle of a regular polygon. What are regular polygons? Regular polygons are regular polygons have equal sides and equal angles. Okay, so let me just first write down the formulas. Sum of angles of any polygon is n minus 2 into 180, and one angle of a regular polygon is n minus 2 into 180 divided by n. So if I'm asking you for a 9-sided regular polygon, I'm going to say that 9 minus 2 into 180 divided by 9. What do I get? I get 140. So formula is to remember, nothing much in this question. I get 140. Okay. Then let's talk about, then let's see what the next question is. I'll deal with circle properties in a bit. I just want to do the other questions first, and then I can come back to circle properties. Okay, this one says work out the size of the largest angle in the Pentagon. What is the sum of angles of a pentagon? If I remember that, that's good. If I don't, I can say that it's n minus 2 into 180, and that gives me 5 minus 2 into 180, 540. So I can say that adding all of these up should give me 540. Okay, that's 416 over 7. Sorry, 8. 8. That's 8. Using 52. So the largest angle should be, let's check, 3 times 52 times 52. That gives me 156. Okay. The next question is about upper bounds and lower bounds. I don't want to go into that right now. Let's see. Okay. This is another question. It says calculate BAC giving each step for giving reasons for each step in your working. Okay. So I want to calculate BAC. The first thing that I notice in this question is that there are parallel lines. So there must be some angles that are equal. Let's talk about that angle first. Okay, I can say that this 58 must be equals to this 58. So yeah, so BCA is also 58 because they are alternate angles. Okay, now if this is 58 and I see an isosceles triangle, then I must say that this is also 58. So I'm going to write another explanation. I'm going to say that CBA is also 58 because of the isosceles triangle. Okay, then for BAC, I can say that for BAC, so BAC, so yes, and since I had to write an explanation for each part, that was necessary. Okay, then it says calculate CDE. Okay, CDE, this angle. Now if I notice I have an entire triangle, let's call that X. Can I say that X plus 58 plus 47 gives me 180? X is therefore 75. Okay. Okay, then it says that in the next part it says that the shaded region M shows part of a regular pentagon. So when I see a regular pentagon, I know that all the angles must be equal. This must be equals to that. And the shaded region N shows of a regular octagon. So again, these angles are equal. Okay, can I calculate X? Yes, if I had both other angles. So one regular angle of a regular pentagon, one angle of a regular pentagon, not one regular angle. Divide by 5. So if you remember the formulas, you'll be able to do the questions correctly. It's just about remembering a simple bunch of formulas for you to calculate. One angle of a regular octagon. So I have 8 minus 2 into 180 divided by 8. 135. So I can say that X gives me 117. ज़ुहैर एक्सटीरियर एंगल के लिए ज़रूरी होता है कि इस तरह की सिचुएशन हो. Let's say if I want to talk about exterior angles, then ये कोई साइड एक एक्सटेंड होनी चाहिए ना, इसको एक्सटीरियर कहते हैं. The problem with this exterior angle is कि if I were to draw an exterior angle, तो फिर ये दो अलग अलग exterior angles calculate करने पड़ जाएंगे. That will be slightly more confusing to explain. But you can, yes, do it that way as well. If you can see the exterior angle properly. Okay, so 5-sided, I can say that the sum of all of these must be 540. अभी हमने निकाला था कि angles of a pentagon are, sum of angles of a pentagon is, something wrong with my iPad today. So 540 आता है. So sum of angles must be 540. So I put down 540. This is 4a plus 320, which is 540. Divided by 4. A is 55. Just wait a moment. Okay. Now this question. It says P, Q, and R, S are vertices of a regular polygon. M is the midpoint of PR. PQ is equals to 14. QM is equals to 7. How many sides has the polygon? Showing your working. So if I wanted to calculate this angle, what would I tell you? That cos of, let's call that x. Cos of x equals to 7 over 14. X would then be cos inverse of 7 over 14. That would give me 60 degrees. If this is 60 degrees, then this must also be 60 degrees. So can I say that one angle of this regular polygon is 120 degrees? Now what's the formula for one angle of a regular polygon? Can I say that it's n minus 2 into 180 divided by n? This should be equals to 120. If I expand this, what do I get? I've cross multiplied this. Yeah, 60n equals to 360. Okay, and n is therefore equals to 360 divided by 60. So it's a 6-sided regular polygon, जिसको हम hexagon कहते हैं. So you see how this question is merging two topics together. They are asking you about trigonometry and angle properties in the same question. Let's look at this one. It says the diagram shows a quadrilateral and a part of a regular octagon. AB is a straight line. Form an equation in X and solve it to find X. So if this is a regular octagon, then all of these angles must be 135 degrees. If this one is 135 degrees, then the one next to it must be 180 minus 135. That gives me 45 degrees. Then this question becomes very simple because I can add up the angles inside a quadrilateral and I can say that they should add up to 360 degrees. (192). 4x equals to 192. X equals to 48. Okay, that was pretty simple. Okay, questions. Then let's do this one last question on angle properties, then we're going to move to circle properties, okay? EMF and GLNH are parallel lines, LM equals to LN, when GLM equals to 126. Okay, when I see such an angle, what my brain quickly does is calculates the other angle next to it. So this should be 54. Okay, so I can say that मैं अपनी working भी लिखता जाता हूँ, it says working लिखते जाएं, so MLN is equals to 54 because of straight line. Okay, then the question is actually asking you for FMN. So yes, so the question is asking you for this angle, but in order to calculate this angle, I must go through this angle and this angle first. So yeah, I can say that let's do calculations. Let's call these x and say that 54 plus x should equal 180. So yeah, so I can say that L and M should equal 63 because of isosceles triangle. Then FMN should equal 63 as well. Why? Because I see a Z being constructed. जब Z बनता है तो उसको क्या कहते हैं? We call those alternate angles. Okay, so I've given you a reason for my working. That's 4 marks for me. Any questions on these? Okay, then let's talk about angle properties of circles. Now, I know that you guys must have done a lot of properties in your classes. What I generally tell people is that if you use a few properties only, you more or less, you will be able to solve most of the questions. Okay? The first property that I tell people is the one with the diameter. That if the diameter is forming an angle anywhere on the circumference of a circle, it's 90 degrees. And isko kya kehte hain? These are called angles in a semicircle or 90 degrees. Sahi hai? Let's call it that. Reasoning bhi pata honi chahiye because the reasoning comes in handy. Sahi hai? This angle and this angle must be equal. Okay? How do I see these angles? मैं कहता हूँ कि angles जो होते हैं वो arc से निकलते हैं. They come out of an arc and they form on the circumference. If they come out of the same arc, then they must be the same angle. How do you describe these? You call them angles in the same segment. Okay, that's the second property. The third property is this, that if you have an angle forming at the center and an angle forming at the circumference, okay, then the relationship is 2x and x. The angle at the center is twice that of at the circumference. Okay, angle at the center is twice that of the circumference. Then the fourth property that I generally tell people is this, of the cyclic quadrilateral, that the opposite angles must add up to 180. So x plus y equals to 180 and a plus b is also equals to 180. This is called what? It's called the cyclic quadrilateral. I can solve most questions using these four properties. Sometimes वो tangent वाली properties आती हैं, they are relatively easy to apply. Tangent and radius always make 90 degrees. But I'm not going to go into that. I'm going to try to solve questions using this only. So yeah, now my idea of solving questions is not to look at the requirements of the question. I know that requirements होती हैं हर सवाल की, लेकिन बहुत सारी requirements होती हैं. I don't want to look at them individually. What I first want to do is I want to apply all the properties that I know of so that I can quickly get to my answers. Okay. So whenever I'm looking at a circle, the first property that comes to my mind is this one with the semicircle. Then I see some triangles and so on. Then I look at these two properties. Are there angles forming from the same arc? So those must be equal. Okay. So without looking at the requirements of the question, what I start doing immediately is that I start calculating. Okay. I don't see a diameter in this question. यहाँ पे कोई diameter नहीं है, ये side में से गुजर रहा है. But I do see कि ये एक arc से जो है वो एक angle center पे बन रहा है और एक circumference पे बन रहा है. तो मैं क्या कहूँगा आपसे कि ये angle जो होगा वो 60 degrees हो जाएगा. So yeah, when this angle is 60 degrees, that solves one problem for me. I don't know if that's required in the question or not, but I also see that this angle must be 240. Okay, because the entire thing is 360, so this must be 240. Then whenever there is an angle forming at the center, I should be able to see an isosceles triangle. So these angles must also be equal. अगर 120 में से minus करके divide by 2 करूँगा तो ये 30 और 30 आ जाएंगे. सही है? Now I still haven't found other angles, but what I see now is that there must be a cyclic quadrilateral somewhere or a quadrilateral. First, when I look at y, I see this, that this is a four-sided figure. So I can say that 240 plus y plus 2y plus 60 should equal 360 degrees. क्योंकि जो है ये एक quadrilateral बन रहा है, बीच में बन रहा है अजीब सा, but it's a four-sided figure, so the sum must be 360. So y जो आ रहा है वो 20 आ जा रहा है. So this becomes 40 and this becomes 20. Okay. Does everybody then see a cyclic quadrilateral forming? I see a cyclic quadrilateral forming. So what I can do is I can tell you that the sum of this and this must be 180. So वो 70 बन रहा है. So this must be 110 degrees. Okay, I solved it reasonably enough. Let's see what the question is asking. It says find x, giving a reason for your answer. So x is 60 degrees because angle formed at the center is twice that of circumference. Okay. Then it says find DAB. Let's see if I have already found DAB. Where is DAB? We've already found that. I know that this is 70. I'm just going to go on and write 70 because I've already spent time calculating it. Find BCD. BCD. Oh, I've already done that too. That gives me 110 degrees. So you see, this is a 6-mark question. I spent a lot of time on my diagram. That tells me that if I were to spend time on my diagram, I would be able to solve questions quickly. Okay, it's just about applying four properties and then remembering sum of angles of a quadrilateral and sum of angles of a triangle. You have to spot the properties, spot other things in the question. Okay, let's look at this one. Now I know that there are a lot of parts that I need to answer. There are about 6 marks in this question as well. But let me just see what I can derive out of the properties that I know. The first thing that I see in this question is that a diameter is forming. So I know that this diameter must create an angle of 90 degrees. So I quickly go on and mark this 90 degrees. If this entire thing is 90, then this must be 22. Okay, this must be 22. Then when I see this triangle, I have 90, I have 52. So I must have something else as well. I have 38 then. 180 minus 90 minus 52. Okay. Okay. Then I see a lot of angles coming from arcs. Let's see if I can apply the second property that I told you, this one. Let's see. This 38 was actually coming up from the arc AB. Do you see another angle coming up from the arc AB? Yes, I do. I see this angle. So this must also be 38 because they're both coming out of the arc AB. Okay. Now then I also see parallel lines in my question. When parallel lines are there, there's usually a Z forming. So I'm just going to extend this line to show you if there's a Z possible somewhere. Okay, let's try to look for that. Okay. Okay. I don't see any angles marked, so I know that this angle must be equal to this angle, but since I don't know this angle, I can't go on and calculate that. So yeah. What other property have I not applied so far? I have not applied the cyclic quadrilateral so far. Let's talk about the cyclic quadrilateral. Do you see B, E, C, D? I do. So I'm going to say that this is 68. Therefore, this must be 180 minus 68. That is going to give me 112. If this is 112, then the angle next to it must also be 68, 180 minus 68. And if that is 68, then this must also be 68. Okay. Then if I have these two angles, what is 68 plus 38? It's 106. Can I calculate this angle then? What's 180 minus 106? 74 degrees. So 74 degrees. So you see, I spent a lot of time solving my diagram. Once I do that, let's see if I have all my answers. Do I have ACB? ACB. 38. Do I have AEF? AEF. AEF. Yes, I have that. 38. What property was I applying? Angles in the same segment. CDE. Do I have CDE? CDE. Yes, 112. BCD. BCD. I have this. I calculated that as 106. Just give me a moment. Okay. So yeah, does that make sense to everybody? Any questions? So my focus is entirely on the diagram. Okay. I am not looking at the options. I'm not looking at the questions that are required. Okay. Now this seems like a tough question, but let's try to do it. I haven't done this before either. It says the diagram shows two circles, each with center O. A, B, C, D, E, and G are points on on the circumference of the large circle, E, F, and G, or points on the circumference of the small circle. Okay. So I know that if there are points on the circle, then there must be a lot of cyclic quadrilaterals. So yeah, and I see tangents as well. That means that must be angles that are 90 degrees. Okay. Okay. It says lines A, C, and FG intersect at 90 degrees at X. Okay. So this is also a 90-degree triangle. If this is 90 degree, then this must be 90 minus Y, and this must also be 90 minus Y. This must also be Y then. So yeah, I'm just looking at the triangle and I'm trying to come up with answers for the triangle. Okay. Okay. Then I see this property where my angle is forming at the center, which is 2y, and there's an angle forming at the circumference, which is the entire thing must be y. So this must also be divided into half y and half y. Okay. Then I see that there are tangents and radius. Tangents and radius. So they must also be meeting at 90 degrees. The entire thing is 90 degrees. This is also 90, this is also 90. Okay. And do you look at, let's call this angle theta. This angle is theta. Can I say that theta plus 90 minus y should equal 90? So theta should actually equal y. So this is y. If this is y, this must also be y. And then if this is 90, then this must be 90 minus y. And this must also be 90 minus y, because I'm looking at this triangle. So a lot of complications here, but that's pretty much the crux of it. This is what this question is about. Okay, these angles are equal. Then what I see in my diagram is that there is a cyclic quadrilateral forming. If this is 180 minus 2y, and let's call this, in fact, these must also be then 90 degrees. Let's call that cyclic quadrilateral. In fact, let's call that beta. The entire thing is beta. Can I say that beta plus 90 minus y plus 90 minus y should equal 180 degrees? And this would give me beta equals to 2y. So again, that would split up into y and y. So this triangle is also y and y. And if these two are y, then this must be 90 degrees. I think I've pretty much solved the diagram here. Let's see what the question is asking. Find each of these angles as simply as possible in terms of y, giving a reason for your answer. GEO. GEO. GEO was what? Y. It was y because angle formed at the center, is twice that of circumference. GCX. GCX. 90 minus y. Okay. Why was this 90 minus y? Because OGC was 90 degrees. OGC was 90 degrees. It was tangent. So here OGC was 90. And then sum of angles of a triangle. So looks like a difficult question on the face of it, but if you concentrate on the diagram only, you will be able to figure out the question. DAB. What's DAB? DAB. Okay, I found this to be 2y. 2y because cyclic quadrilateral. Okay, then the last one. But in fact, that's it. Then I have to prove congruence to you. Let's not go into that right now. But that is pretty much the crux of it. Okay, any questions? Any part that you don't understand in the calculations that I've done? So it's slightly tough, but I think manageable question where you have to come up. The idea is that if you concentrate on the diagram, you will be able to solve the question. Okay, let's try to do this last question for today, and we'll call it a day at that point. Okay, I see parallel lines. What immediately strikes me is that this must be 66 because I'm talking about uh, alternate angles between parallel lines. If this is 66, then this must be 180 minus 66 minus 35. What does that give me? 180 minus 66 minus 35. That gives me 79. If this is 79, then I must also have this. This is also 35 degrees because again I see alternate angles. Okay. If I solve this 79 and 35, then this must also be 66. And if I want to calculate this angle, I can say that I could say that this is a cyclic quadrilateral. So this would be 180 minus 79 minus 35. What does that give me? It gives me 66 again. If this is 66 and that is 66, then I can calculate this one as well. 180 minus 66 minus 66. 48. Okay, so I've solved the entire triangle right now, circle right now in front of you without even looking at the questions. So yeah, it says find PTS, giving a reason for your answer. PTS was 66 degrees. Why? Because they were alternate angles. Okay, PTS. PTS was this. PTQ. Have I calculated PTQ? I've calculated almost everything. So I got that at 79. It's not asking me for a reason. Okay. Then it's asking me that complete the statements below to show that PQT is congruent to triangle RTQ. Let's do this as well. It's telling you how to prove congruency so that you don't need to worry about that. PTQ and RTQ. RTQ. So here these two triangles are congruent. How do I prove that these are congruent? It's asking me for angles to be proven equal. PTQ. PTQ was 79. So which other angle is 79? This one. So I'm going to say that it's TQR. It's equals to angle TQR. Then angle PQT. PQT. This one. 35 कौन सा है यहाँ पे 35 ये है. QTR. QTR. How do you prove congruency? If you've proved two angles, then you need to prove a third side to me. So yeah, this side basically is the same in both triangles. I cannot tell you a third angle. When you tell me three angles, that is about proving similarity. That's not about proving congruence. So in this case, I'm going to say that QT is common. So what condition have I proved to you? I've proved to you the condition ASA, that I've proved to you that two angles and their inclusive side is equal. Therefore, these two triangles are congruent to one another. Okay, there are some congruency details that I haven't talked about, but this is what you should be knowing from your earlier understanding of congruency, that I've proved that two angles and their inclusive side is equal. Okay, any questions? I'm going to stop here. There are more questions that I could do, but I've told you the crux of the uh, topic in terms of what tricks you need to apply and how do you need to solve questions. So yeah, you can try more questions out and get back to me if you have trouble. Okay. Thank you. Allah Hafiz.